All right, Unit 6, Day 2, Properties of a Rhombus. Today we're going to be proving a shape is a rhombus. So first of all, what do we know about a rhombus? Opposite sides are parallel. Sound familiar, right? Parallelogram. Also, opposite sides are equal. Opposite angles are equal. Adjacent or consecutive angles are supplementary. The diagonals bisect each other. So those 5 are all the properties of a parallelogram. What makes a shape a rhombus are these 3 additional, actually 4 additional properties. Number 1, 4 equal sides. And that's the one I want you guys to highlight. That's what we're going to use in the proof today. I also know the diagonals are perpendicular. And the diagonals bisect the angles. That's just a review from Unit 4. We are not going to actually work with the diagonals a whole lot with a rhombus. I will just give you a shape and ask you to prove it's a rhombus, and you're going to do that by showing it has 4 equal sides. All right, so we are going to prove a rhombus very similar to the way we proved a rectangle, except the conclusion is going to be different. We're going to use 4 distances to prove it has 4 equal sides. The work will be exactly the same as the the parallelogram proof, with the exception of all 4 sides are going to be the same length. Let's look at an example. Prove ABCD is a rhombus. It doesn't matter where we start here. We don't have to match up opposite sides because we know all 4 of them are going to be the same. It'll get a little bit repetitive, but remember, because it's a proof, we have to show all of our work. So I want the distance from A to B. I'll just start there. Using our distance formula, delta x is 2, delta y is 4. So I get 2 squared plus 4 squared. 2 squared is 4, 4 squared is 16. Add those up, you get square root 20. All right, pick another side, AD, let's say. And like we said, you notice that these numbers are going to be the same. It's still going to be 2 squared and 4 squared. You have to show the work. If you're using this formula, you have to show me on the grid delta x and delta y. Otherwise, you'd have to plug into the longer formula. All right, distance from B to C, square root, let's see here. That's 2, 1, 2, 3, 4. Yep, same lengths. 2 squared plus 4 squared. Square root 20 again. And the final side, distance from C to D. That's 2, 1, 2, 3, 4. And again, we get square root 20. So now what we notice is not only are the opposite sides equal, all 4 sides are equal. So we have to make a conclusion here looking at this. And that conclusion is AB equals AD equals BC equals CD. So we make a statement about all 4 sides, not just the opposite sides. And our conclusion is then A, B, C, D is a rhombus because it has 4 equal sides. Example 2, prove ABCD is a rhombus. So again, we're going to do 4 distances. Distance from A to D. Delta x here is 4, delta y is 3, 4 squared plus 3 squared. I put this into the calculator, 16 plus 9, square root 25. Now you can simplify square root 25 if you want to and make it 5, or you can just leave it square root 25 because all we're going to do is compare the 4 sides and they all better be the same. Next, distance of DC. Delta x is 3, delta y is 4, but it doesn't matter what order you put these numbers underneath the radical. It's still 3 squared plus 4 squared, which is square root 25. Distance from A to B. So that is 3, that is 4. Make sure you show that work. 3 squared plus 4 squared, that's square root 25. And finally, distance from B to C. That's 4, that's 3. So I know it gets a little repetitive, but you have to show all of that work. You have to show the lengths on the diagram, and you have to make this little conclusion here. AD equals DC equals AB equals BC. You just set them all equal. So you've just shown that all 4 sides are equal, and the last thing you do is your little conclusion that says ABCD is a rhombus because it has 4 equal sides. And that concludes lesson 6.2.